Good day, everyone. Our next lesson will be software engineering concepts and applications. Our learning outcomes for this lesson are as follows. Let us first define software engineering. I have listed three definitions of software engineering. According to Fritz Bauer, software engineering is the establishment and use of sound engineering principles in order to obtain economically software that is reliable and works efficiently on real machines. According to the Institute of Electrical and Electronics Engineer or IEEE, software engineering is the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software that is the application of engineering to software. And lastly, Technopedia.com defines software engineering as the process of analyzing user needs and designing, constructing, and testing end user applications that will satisfy these needs through the use of software programming languages. It is the application of engineering principles to software development. As you can see, software engineering is present from the start of the system development, construction, up to implementation and maintenance. I hope these definitions can help you understand what software engineering means. Let us now identify the 8 characteristics of software engineering, namely functionality, reliability, efficiency, usability, maintainability, portability, robustness, and integrity. Let us discuss them one by one. Functionality. Functionality means the developed software must perform and meet its intended purpose. The next characteristic of software engineering is reliability. Reliability means that the software is dependable. It has the capability of maintaining its level of performance for a given period of time. Another characteristic of software engineering is efficiency. Efficiency refers to the ability of the software to use system resources. It can be hardware, computer networks, data being processed by the system in the most effective and efficient manner. Number 4, usability. Another characteristic of software engineering. Usability refers to the extent to which the software can be used with ease. Example, if a user encounters an error while using a system, can the system still be used to perform its other tasks? Usability also refers to the amount of effort or time required to learn how to use the software. When training, the intended users of the system can quickly learn how to use it. The next characteristic is maintainability. System maintenance can sometimes be costly. How easily modifications can be made in a software system is extended its functionality, improvement, performance, or correct errors should be easy and inexpensive. The next characteristic is portability, a set of attributes that has the ability of the software to be transferred from one environment to another without or minimum changes. We know software upgrades moves at a fast pace. The ability to migrate to a more updated version must be taken into consideration. We are now down to two. The next characteristic is robustness. Robustness refers to the degree to which the software can keep on functioning in spite of being provided with invalid data. There are times an error may occur while using the system because of invalid data. The ability of the system to handle this data is very important. The last characteristic of software engineering is integrity. Integrity refers to the degree to which unauthorized access to the software data can be prevented. Your system should be able to protect and secure important information of an organization. And those are the characteristics of software engineering. Again, functionality, reliability, efficiency, usability, maintainability, portability, robustness, and integrity. Let us now go to the different issues encountered during software engineering practices or practice. Difficulty of software projects meeting delivery deadlines. Some of the cause may be modifications in the process, conditions, and many more. And because of this, delays happen. High cost of software development. The cost of manpower, hardware, and software to name a few. Errors in delivered software after extensive testing. These can be caused by program logic errors while processing the data and other reasons. High cost in time and effort in maintaining software is another issue. And lastly, problems measuring progress during software development and maintenance. So these are the issues encountered during software engineering practice. So the question now is, why do you think these issues arises? These issues may be caused by obsolete hardware, software compatibility, and wrong practices during software development. So how do we resolve these issues? So basic solutions to solve software engineering issues. So in order to build a high quality software, a framework called software process is needed. Below are some common activities used in process model. First, we have to understand the problem. After understanding and identifying the problem, the next step is to plan a solution. So, after planning the solution or formulating a solution, make sure to carry the plan out. Once the solution has been implemented, the next is examine the result for accuracy. Make sure all problems has been resolved and the intended results are met. We now go to the four layers of software engineering. And they are tools, methods, process, and quality focus. Let's go to tools layer. Tools layer provides computerized or semi-computerized support for the process. These can be flowcharts, algorithms, prototypes, and many more. The next layer is the method layer. So the method layer provides technical knowledge for developing software. These layers covers a broad array of tasks that includes requirements analysis, design, coding, testing, and maintenance phase of the software development. The next is process layer. The process layer allows the development of software on time. It defines an outline for a set of key process areas that must be acclaimed for effective delivery of software engineering technology. Some of the tools that can be used in monitoring the development of the system is a Gantt chart or an ER diagram. If I'm not mistaken, this has been taught to you in your systems analysis and design. Lastly, we have the quality layer. So the quality layer is the characteristic of good quality software. In order to have a good quality software, remember, it must have the 8 characteristics of software engineering. Again, namely, functionality, reliability, efficiency, usability, maintainability, portability, robustness, and integrity. And that concludes this lesson. So here are the references used in this lesson.